We begin our journey at the center of everything we know, our very own sun. From here, the solar system stretches out to the frozen orbit of Neptune. Past the helipause, we leave the sun's influence and enter the silence of interstellar space. Suddenly, a humongous shadow looms, the supermassive black hole known as Ton 618. This monster is 40 billion times more massive than our sun. But even Ton 618 is outclassed by Phoenix A, a behemoth 100 billion times the mass of the sun. What would happen if these two unstoppable forces collided? In this exploration, we're going to smash the biggest things in the universe into each other. To understand these collisions, we must first grasp the terrifying scale of a black hole. Stellar mass black holes are the remnants of stars that have burned through their fuel. These dense bodies swallow everything that drifts by, including light itself. A stellar black hole can be smaller than the moon, yet 100 times more massive than our sun. On the other side of the scale, supermassive black holes lurk at the center of galaxies. Take J1601 plus 3113, which is the same diameter as our sun, but 100,000 times heavier. In the Circinus galaxy, there is a black hole weighing more than 1 million suns. Closer to home, Sagittarius, a star sits at the heart of our Milky Way. This black hole has a mass of over 4 million suns, a true heavyweight. But even Sagittarius A star is puny compared to the monster in Cygnus A. It dwarfs our entire solar system while generating unbelievable amounts of energy. This titan weighs in at over 2 billion suns, a figure that boggles the mind. Then there's M87, the first black hole to ever be directly imaged by humans. It weighs 5 billion suns, yet it's just a bug compared to Ton 618. Ton 618 is so large it would engulf our solar system far beyond the Oort cloud. With a mass of 66 billion suns, it seems like the ultimate heavyweight champion. But a new contender has been found 8 billion light-years away, Phoenix A.
This black hole is primordial, likely forged shortly after the Big Bang itself.
It is currently growing, devouring an entire sun's worth of mass every single week. Imagine if Ton 618 and Phoenix A were caught in each other's gravity. This wouldn't be a sudden crash, but a slow cosmic dance lasting millions of years. Two singularities bound forever once they pass the point of no return. They would spiral into an ever-tightening orbit, infinitely close yet infinitely far. As they reach the critical distance, their shapes begin to distort and stretch. After millennia of waiting, the final connection happens in a flash. It is an incalculable cosmic bloop as the two become one. The result is a stupendous black hole larger than anything we can conceive. Hundreds of billions of solar masses merging, sending ripples through the fabric of space-time. These gravitational waves shimmer across the universe for billions of years. Then, the new giant goes back to consuming everything in its path as if nothing happened. But what could possibly be bigger than a collision of black holes? The answer lies in the collision of entire galaxies. To comprehend the violence of a cosmic collision, we must first dissect the fundamental anatomy of the black holes themselves. On the lower end of the cosmic scale, we encounter stellar mass black holes, the condensed corpses of ancient massive stars. These compact monsters can be smaller in diameter than our own moon, yet they pack the mass of 100 suns into that tiny volume. Their density is so extreme that the fabric of space-time curves sharply around them, creating a point of no return known as the event horizon. But as we move toward the center of galaxies, the scale of these objects shifts from the stellar to the supermassive. Consider the black hole J1601 plus 313, which appears roughly the same size as our Sun but carries 100,000 times its mass. As we scale up further to the Circinus galaxy, we find a black hole weighing more than 1 million suns. This Leviathan is so vast, it would barely fit in the orbital gap between Venus and Earth. Our own home, the Milky Way, hosts Sagittarius A, a black hole with the mass of 4.3 million suns. Yet, even Sagittarius A is a mere dwarf compared to the terrifying power of Cygnus A. Cygnus dwarfs our entire solar system, generating more radio energy than almost any other source in the known universe. It consumes endless amounts of spaceborne material, fueling a hunger that weighs over 2 billion suns. Then, there is M87 Turtle, the first black hole ever directly imaged, weighing in at over 5 billion suns. These are the heavyweight champions of the cosmos, but even they tremble before the true titans like Ton 618. To understand the physics of a collision between such objects, we must look at how gravity behaves at these impossible scales. In a collision, the two black holes do not simply hit each other, they begin a complex gravitational interaction. The primary difference between stellar mass and supermassive collisions lies in the sheer volume of spacetime they displace. Stellar mass black holes collide with a sharp, high-frequency chirp of gravitational waves. Supermassive black hole mergers, however, produce low-frequency rumbles that can last for millions of years. This difference is due to the size of their event horizons, which act like the surface area for the collision. For a stellar mass black hole, the event horizon is just a few dozen kilometers wide. But for a supermassive giant, the event horizon can be larger than the entire solar system. When these giants approach, they don't just pull on each other, they stretch the very atoms of the surrounding space. This is tidal force at its most extreme, capable of ripping apart any star that wanders too close. The physics dictate that, as they orbit, they lose energy by radiating it away as gravitational waves. This loss of energy causes their orbits to decay, drawing them closer and closer over eons. As the distance shrinks, the speed of their orbit increases to a significant fraction of the speed of light. The accretion disks, the swirling rings of gas around them, begin to merge and clash. Friction within these colliding gas clouds reaches temperatures in the billions of degrees. This process creates some of the brightest light in the universe, despite coming from objects that are purely dark. But the real action is happening at the singularity, where the laws of physics as we know them begin to break down. Scientists call this the final parsec problem, a mystery of how these giants bridge the last bit of distance to merge. They need to lose momentum, often by scattering nearby stars or interacting with the surrounding gas. Once they overcome this barrier, the final plunge is inevitable and extremely fast. The resulting merger creates a new, even more massive black hole, though it is slightly less heavy than the sum of its parts. That missing mass is converted entirely into pure energy in the form of gravitational waves. This conversion is so efficient that a single merger can release more power than all the stars in the observable universe combined. These waves act as the only record of the event, traveling through the void for billions of years until they reach our detectors. We are now beginning to listen to the sounds of these titans as they reshape the universe around them. But while black holes are the masters of the dark, a much larger dance is about to begin between the giants of the light. The pitch-black void of space becomes the stage for a performance that defies human comprehension. Ton 618 and Phoenix A are drawn together by an irresistible gravitational pull that spans millions of light years. This is not a violent crash, but a slow and deliberate spiral toward a shared destiny. Over millions of years, the two leviathans begin to circle each other in an ever-tightening orbit. Their massive bulks churn the very fabric of space-time, creating ripples that move outward at the speed of light. As they draw closer, the tidal forces between them grow to unimaginable levels of power. The black holes begin to distort each other's perfect spherical shapes into elongated oval forms. They reach a critical distance where their fates become permanently and irrevocably entwined. For a brief moment, they exist as two shapeless voids morphing and stretching toward the inevitable touch. When they finally make contact, the connection happens with a speed that defies the scale of their size. This cosmic merger results in a stupendous bloop as two of the universe's largest objects become one. The new entity is a gargantuan black hole with a mass exceeding hundreds of billions of suns. The merger sends out powerful gravitational waves that shimmer across the entire universe for billions of years. This new king of the dark now sits at the center of its galaxy, ready to consume anything that drifts too close. It continues its eternal growth, devouring matter and energy at an unprecedented rate. To the rest of the universe, it may seem as though nothing significant has changed in the deep silence. But the scale of this new giant has shifted the gravitational balance of its entire local cluster. It is now more massive than anything we can truly conceive, a monument to cosmic power. The energy released during the final milliseconds of the merger was greater than the light of all stars combined. How many of these stupendous mergers have already occurred since the dawn of time? These primordial behemoths may have been forged in the very fires of the Big Bang itself. Their presence is a reminder that even the most powerful objects in the universe are subject to the laws of motion. As the new black hole settles into its dominance, the galaxy around it enters a new era of stability. The once divided masses are now a single, unified force of nature. Beneath the event horizon, the two singularities have become one, hidden forever from our eyes. This new monster will outlive every star currently burning in the night sky. It is a graveyard of matter, a repository of information that can never be retrieved. Yet, as dominant as these black hole mergers are, they are only one part of the story. The dance of giants is not limited to the dark, singular points of gravity. There are even larger structures composed of billions of stars that are currently on a collision course. These galactic mergers are events of such scale that they take billions of years to complete. What will happen when these two massive collections of stars finally meet? The forces at play will be different from the clean merger of black holes. Entire spiral arms will be ripped apart and cast into the intergalactic void. Yet, in the midst of this destruction, new life and new stars will be born. The gas and dust scattered by the collision will become the fuel for future generations of celestial bodies. It is a cycle of death and rebirth on the grandest possible scale. But even as these massive structures combine, there are things that remain hidden in the chaos. Deep within the core, the original supermassive black holes have survived and are now seeking each other out. As the stars of the Milky Way and Andromeda begin to mingle, A darker, more personal collision is brewing at the heart of it all. As the stars of the Milky Way and Andromeda begin to mingle, a darker, more personal collision is brewing at the heart of it all. While black holes merge with a sudden cosmic bloop, the collision of two entire galaxies is a far more ethereal affair. Scientists often describe this impending event as two ghosts passing each other in a long, dark hallway. In about 5 billion years, our home galaxy will face its greatest transformation as the Andromeda galaxy arrives. Despite the terrifying scale of the event, the sheer emptiness of space dictates the rules of engagement. Gravity is the invisible conductor of this multi-billion-year symphony, pulling the two giants together across millions of light years. The long, whirling spiral arms of the Milky Way will begin to shiver and distend as the first gravitational tides hit. Extreme tidal forces will rip stars from their regular orbits, casting them into the unfamiliar territory of the intergalactic medium. Dust and gas will be scattered everywhere, creating massive clouds that glow with the heat of the interaction. Both galaxies will warp and distort, losing their familiar billion-year-old shapes as they loop back toward each other. It is a slow-motion dance that unfolds over eons rather than minutes. Even though there are over 100 billion stars in each galaxy, the chances of two stars actually hitting each other are nearly zero. On average, stars in these galaxies are separated by 5 whole light years, which is about 47 trillion kilometers. This means that while the galaxies merge, the individual solar systems will likely remain intact and unbothered. The merger will eventually create a brand new, much larger galaxy that scientists have already named Milky. As the bodies of the galaxies blend, the supermassive black holes at their centers will begin their own final approach. Sagittarius, a star from our galaxy and its counterpart in Andromeda, will eventually undergo that famous bloop to become one. For a hypothetical observer on a planet, the night sky would transform into a breathtaking display of cosmic fireworks. This process is a spectacular, billion-year-long watch party that is surprisingly non-destructive to the stars themselves. However, while the stars mostly miss each other, the same cannot be said for the massive gas and dust clouds. These collisions of gas trigger a frantic burst of star birth, populating the new galaxy with brilliant blue giants. Eventually, the vibrant spirals of our youth will be replaced by the quiet, settled glow of an elliptical giant. It is the inevitable fate of our corner of the universe, a destiny written in the language of gravity. But what of the rare exceptions where things actually do make contact during these mergers? While rare, the sheer number of objects means that somewhere in the chaos, planets will find themselves on a collision course. To understand these rare impacts, we must look at the sumo wrestlers of the planetary world. Our Jupiter is a giant, but it is a dwarf compared to the massive gas bags found in the deep reaches of space. Meet Rox 42b, a young gas giant with the mass of 9 Jupiters packed into a similar diameter. In the other corner stands Toy 4603b, a heavyweight behemoth weighing as much as nearly 13 Jupiters. When two such titans are forced together by the gravitational upheaval of a galactic merger, the result is a planetary wump of epic proportions. Unlike the solid impact of rocky worlds, these gas giants merge their atmospheres in a swirling, violent embrace. Huge plumes of liquid hydrogen and helium are blasted into the vacuum of space during the initial contact. As they combine, they create a new entity that challenges our definition of what a planet actually is. Crossing the critical mass of 13 Jupiters, the merged object ignites with a low internal fire. It has become a brown dwarf, a failed star that isn't quite a planet, but isn't a true star either. These hybrids are some of the strangest inhabitants of our universe, born from the debris of cosmic smash-ups. The merger of galaxies is not just a destruction of the old, but a violent nursery for the new. As the Milky Way and Andromeda continue their 5 billion year approach, we are reminded of how small our world really is. Yet, even in this ghostly merger, there are forces that can trigger a far more explosive end for the stars themselves. For when the ghosts stop passing and the giants actually decide to strike, the very fabric of the stars will be put to the ultimate test. To understand the impact on stars, we must first confront the terrifying loneliness of their existence. As the Milky Way and Andromeda begin their multi-billion-year embrace, the individual stars are caught in a gravitational tug-of-war. You might expect a symphony of explosions, a frantic pinball game of suns crashing into suns. However, the reality of space is far more hollow than our imagination suggests. Within our galaxy, stars are separated by an average distance of 5 whole light years. That is an incomprehensible distance of 47 trillion kilometers between every glowing orb. If the stars were the size of ping pong balls, their nearest neighbors would be thousands of miles away. Because of this, when galaxies collide, the stars themselves rarely ever touch. They simply sail past one another like ships in the dead of night. But while they may not collide, they do not escape the encounter unchanged. Tidal forces generated by the combined mass of the passing galaxy begin to warp the orbits of billions of suns. Entire solar systems are flung out into the intergalactic wilderness, far from the warmth of the galactic center. Some stars become lonely wanderers, ejected into a void so deep they will never see a neighbor again. Others are compressed into new, dense clusters as gas clouds are forced to mingle and collapse. This process is a spectacular billion-year watch party for any observer lucky enough to be at the right distance. Yet, for the worlds orbiting these stars, the view would be a nightmare of changing skies. Gravity doesn't just move stars, it tears at the very fabric of their planetary families. While the suns avoid contact, their gas and dust clouds smash together with incredible heat. These collisions trigger massive bursts of star formation, a final gasp of creation in a dying system. The ghosts continue their hall walk, oblivious to the tiny specks of life they might be unsettling. It is a comparatively non-destructive process when viewed from a distance. But rare does not mean never in a universe of infinite opportunities. In the dense core of the merging galaxies, the math of empty space begins to fail. Here, gravity is too thick, the stars too crowded, and the momentum too great to simply pass by. For the few unlucky suns that do find themselves on a direct collision course, the result is total annihilation. These rare events are the car crashes of the cosmic freeway. Even planets, usually too small to matter, are sometimes caught in the crossfire. When these rogue worlds meet, we witness a battle of mass that defies planetary logic. We must look closer at these individual accidents to see the true power of cosmic impacts. What happens when the sumo wrestlers of the planetary world, the largest gas giants, decide to strike? They aren't ghosts, they are solid, massive, and ready to merge. Their impact isn't a silent passage, but a crushing union of elements. The distance between stars may protect the galaxy at large, but it offers no safety for the giants within it. Every billion-year passage leaves a trail of these hidden casualties. The Milky Way will eventually settle into its new identity, a massive elliptical named Milky. The billions of ghosts will have finally found their seats in this new grand theater. Yet some objects are too massive to simply settle down without a fight. We have seen the ghosts pass, but now we must watch the titans collide. The era of the planetary sumo wrestlers is about to begin. For as the gas bags burst and the heat rises, a new kind of failed star is waiting to be born from the wreckage. The wreckage of the cosmos often gives rise to monsters we can barely comprehend. We now shift our focus from the vast emptiness of galaxies to the heavy hitters of the planetary world. Imagine two planetary sumo wrestlers, Rox 42BB and 2i 4603b, locked in a gravitational embrace. Rox 42BB is a gas giant so massive it teeters on the very edge of being a star. Its opponent, Toist 4603b, is nearly 13 times the mass of Jupiter, a dense and heavy heavyweight. As they approach, the space between them is no longer empty, but filled with screaming winds. Tidal forces begin to stretch the planets into egg-like shapes, distorting their perfect spheres. The upper atmospheres touch first, creating a friction-induced firestorm that spans thousands of miles. The sheer density of these worlds means that this is not a soft impact, but a crushing blow. Shock waves ripple through the planetary cores, traveling at thousands of miles per second. Massive plumes of metallic hydrogen are ejected into the surrounding space. The magnetic fields of the two giants clash, creating auroras that would blind any observer. As the planets sink into one another, the heat generated by compression becomes unbearable. The rotational energy of the two bodies is converted into a spinning vortex of unimaginable scale. This is not just a collision, it is a metamorphosis of planetary matter. The pressure at the center of the merger begins to climb past anything seen in a normal planet. Gravity begins to take over the role that once belonged to simple chemistry. For a moment, the entire system is silent as the physics of the crash settles. But the silence is a lie, hiding the growing heat within the new planetary core. When two gas giants this size combine, they often exceed the brown dwarf limit. The atoms at the center are being squeezed so tightly that they begin to vibrate with fury. The planet's combined mass starts to pull in every piece of stray debris from the collision. The temperature in the core reaches a staggering 1 million degrees. This is the birth of a failed star, a celestial body that is neither planet nor sun. Its atmosphere is no longer a simple mixture, but a churning sea of exotic elements. The gravity on the surface would crush any spacecraft into a thin sheet of atoms. The energy released in the first hour of the collision is more than our sun produces in a year.
We are witnessing the ultimate recycling program of the universe.
But what happens to the moons that once circled these giants? They are caught in a gravitational pinball machine tossed between the clashing giants. Most are destroyed, turned into the very dust that will eventually form new rings. The resulting object is a super Jupiter, a class of world that defies our local definitions. It hums with radio energy, a lighthouse in the dark of the system. Yet, the most dangerous part of this transformation is yet to come. The density has reached a critical threshold where light can no longer easily escape the interior. This planetary sumo match has ended not in a winner and a loser, but in a fusion. The new world is so heavy that it begins to sink toward its host star. It will soon face a new enemy, the tidal forces of a sun. But inside that dark, heavy core, something even more profound is happening. For as the pressure reaches the breaking point, the planet begins to glow with a light it was never meant to have, as the first sparks of nuclear fusion prepare to ignite. The internal temperature of the newly merged planetary mass skyrockets beyond millions of degrees. Gravity, the relentless architect of the cosmos, begins to crush the core with a force that defies imagination. This isn't just a larger planet anymore, it is something far more dangerous. To become a true star, an object must be massive enough to fuse ordinary hydrogen. Our combined giants, ROX 42b and TOI 4603b, fall just short of that solar scale threshold. However, they have reached a secondary, more volatile limit known as the deuterium burning limit. At 13 times the mass of Jupiter, the physics of the object undergo a fundamental transformation. The first sparks of nuclear fusion ignite, turning the dark gas into a glowing ember. This is the birth of a brown dwarf, the failed star of the universe. It is too massive to be a planet, yet too small to be a sun. The collision has fundamentally rewritten the destiny of these two worlds. Inside the dwarf, the deuterium fusion generates an immense outward pressure that counters the collapse. This internal fire will burn for billions of years, but it will never get any hotter. Clouds of molten iron and silicate dust swirl in its atmosphere, creating a hellish weather system. Watching this transition is like seeing a caterpillar fail to become a butterfly, remaining stuck in between. Yet, in this collision, we see the very mechanism that populates the galaxy with these hybrid objects. But what happens when the colliding objects aren't just failed stars? What happens when two massive, fully formed stars decide to occupy the same space? This isn't just a change in state, it is a recipe for total stellar annihilation. In the heart of the most crowded star clusters, stars are forced into a violent mosh pit. Here, gravity is a cruel master, pushing neighbors into a fatal embrace. These collisions can lead to a strange phenomenon known as a blue straggler. By merging, two dying stars can rejuvenate themselves, appearing younger and more massive than they should be. But not every merger is a rebirth. Some are a death sentence for everything nearby. The kinetic energy released in a head-on collision between stars is enough to shatter the very fabric of the system. We are moving from the realm of failed stars into the realm of stellar titans, where the stakes are no longer just a glow in the dark, but the lighting of a fuse. Consider the most massive stars in the galaxy, millions of times brighter than our sun. When these titans clash, the laws of physics are pushed to their absolute limits. This isn't just about heat. It's about the very elements themselves being forged in the fire of impact. The resulting explosion can be seen across the entire galaxy, a beacon of destruction. The brown dwarf we just witnessed was merely a whisper in the cosmic wind. But it taught us a vital lesson. Mass is the ultimate currency of the universe. And when you accumulate enough mass in one place, the universe creates something new. Sometimes it's a failed star, sometimes it's a rejuvenated blue giant. But always it is a testament to the power of the collision. We are now ready to leave the world of gas and fire behind. For there is a level of collision that transcends even the death of a star. A collision where the very light itself cannot escape the carnage. As the blue giants prepare to smash, something much darker is watching from the center of the cluster, its gravity already beginning to pull the very fabric of reality apart. The dark gravitational pull from the cluster's core finally drags the two massive blue stars into a terminal trajectory. These stellar titans are not merely passing by, they are locked in a high-speed, head-on collision course. To understand this final impact, we must look at the sheer energy stored within their burning hydrogen cores. As the outer atmospheres touch, a bridge of plasma forms between the two dying giants. Tidal forces begin to rip away the gaseous layers, exposing the scorching interiors to the cold vacuum. The speed of their approach reaches millions of miles per hour as gravity becomes an irresistible vacuum. Impact begins not with a sound, but with a shock wave that compresses the gas to impossible densities. In an instant, the kinetic energy of two entire worlds is converted into pure thermal radiation. Huge plumes of iron and helium are ejected into the surrounding nebula like a cosmic fountain. If the stars are massive enough, this collision will trigger a total stellar annihilation. However, a different and more creative outcome often occurs in these dense stellar neighborhoods. Instead of being destroyed, the two stars can merge into a single, much larger entity. This new star is born with a fresh supply of hydrogen fuel brought in from the outskirts of the original pair. Astronomers call this miraculous survivor a blue straggler. It appears much younger and hotter than its surrounding companions, defying the laws of stellar aging. It is a vampire of sorts, born from the lifeblood of two fallen giants to live a second life. But even the mighty blue stragglers must eventually face the reality of the cosmic cycle. We have seen how collisions can create life-giving heat or total darkness. From the smallest gas giants to the largest black holes, the universe is a theater of constant impact. These smash-ups are the primary drivers of evolution on a galactic scale. Without these collisions, heavy elements would never be distributed across the stars. Every atom in our bodies may have been forged in the fire of an ancient celestial collision. We are the children of chaos, born from the most violent events imaginable. As the Milky Way and Andromeda draw closer, our very home prepares for its final dance. But this collision will not be an ending, but a new beginning for a combined supergalaxy. The stars will find new orbits and new planets will form in the debris of the old. The universe continues to recycle its beauty through destruction. We have witnessed the power of Ton 618 and the elegance of planetary mergers. We have felt the gravitational ripples of black holes merging into gods of gravity. And we have seen the birth of brown dwarfs from the wreckage of gas giants. This journey through the greatest smash-ups has shown us the raw mechanics of reality. Every ending we have seen is merely the setup for a much larger story. The cluster core, once a place of violent attraction, now settles into a new equilibrium. Gravity, the ultimate architect, has finished its latest masterpiece. As we fade from this cosmic battlefield, we carry with us the knowledge of our origins. The universe remains a place of mystery, power, and unending wonder. These collisions remind us that even in the vast cold of space, there is heat, light, and progress. Our story is just one small ripple in an ocean of cosmic events. We watch the stars not as strangers, but as fellow travelers in the great smash-up of time. In the end, we are all part of the same eternal, explosive, and beautiful dance of the cosmos.